This video is for lesson 5-1, finding distance on the coordinate plane. Our learning goals are to derive the distance formula. You've actually used this already in algebra class. And then the other learning goal, use that distance formula to find the distance between 2 points on a coordinate plane. In a previous lesson, we used number lines to determine distance and to locate the midpoint of a segment. Number line is one-dimensional. It only goes left and right. In this activity, we'll explore the concepts of distance and midpoint on a two-dimensional coordinate plane. That would be your x and y axis. Use the coordinate plane and follow the steps below to determine the distance between point P, located at 1, 4, and point Q, which is located at 13, 9. So here's a drawing of that, and underneath the drawing, here are the steps that I followed to create the drawing. First, plot the points P at 1, 4. So at the origin, I went right 1, up 4. This purple dot is P. And then I graphed point Q at 13, 9. So from the origin, I went to 13 on the x-axis, and then up to 9 on the y-axis, and that purple dot is Q. Then draw a segment PQ, which you see the red diagonal segment. Number 2. Draw a horizontal segment PR. So right across there until I reached how far Q was. And then from Q I drew a vertical segment downward, creating a right angle here. The reason for doing that is to create this red right triangle shape. Question 3. What are the coordinates of point R? So this green dot is at 13, 4, which is written here. Now question 4a, what is length PR, the length of the horizontal leg of the right triangle? So P was located at 1, and then R was at 13. So from 1 to 13 is 12 units. Question B, what is length QR, the length of the vertical leg? So from Q to R, how long is this? Well, Q was up here at 9, and R was at 4. And 9 subtract 4 is 5 units. Question C, explain how to find those two numbers. Well, what I did was I used the absolute value of the difference of the x coordinates to get the 12. To figure out the 5, I used the absolute value of the difference of the y coordinates. This idea was from the last lesson of to find distance between two numbers, you can subtract them in either order and take their absolute value. Well, you saw that red right triangle, and because it's a right triangle, we can use the Pythagorean Theorem to find length PQ. So the Pythagorean Theorem is a squared plus b squared equals c squared. For a, use the 12. For b, use the 5. And then the original thing we were asked, the distance from P to Q, that can be used as the letter C. 12 squared is 144, 5 squared is 25. Adding those together is 169 equals PQ squared. To get PQ alone, use a square root. And the square root of 169 is 13. So question 6, what is the distance between points P and point Q? It's 13 units because length PQ is 13. Number 7. How do you know that the triangle you drew is a right triangle? Well, the reason that I know that is because that horizontal, or that red line that I drew across, it was horizontal. And then the one that came downward, that was vertical. And I know that a horizontal and a vertical line intersect at a 90-degree angle. The term for that is perpendicular. Now, number 8, what relationship do you notice among the coordinates of points P, Q, and R? Well, R was at 13, 4, and so I noticed that it has the same x coordinate as point Q. That x coordinate's 13, and so is that. And I know that point R has the same y coordinate as point P. So point R's y coordinate was 4, and point P's y coordinate was 4. Here are some check your understanding questions, so I'll pause the video. Although the method you just learned for finding the distance between 2 points will always work, it may not be practical to plot points on a coordinate plane and draw a right triangle each time you want to find distance. Maybe the dots are just so far apart that there's no way to graph it easily on paper. Instead, you can use algebraic methods to derive a formula for finding the distance between any 2 points. Start with any 2 points. Because we're doing this as a formula, we're going to use variables to represent them instead of specific numbers like in our last example. So for our first point, let's use the letters x and y to be its x and y coordinates. So x1 and y1 are the x and y coordinates of the first point. Over here on this picture, I'm just randomly choosing a location and putting the dot there at x1, y1. Now I'm also randomly choosing some other location and putting a dot there and using the variables x2 and y2 to be its coordinates. Now visualize using these points to draw a right triangle. So exactly the same technique that we did on our example previously. Remember that we had located a point here in the last problem. We actually called it point R, and we were able to find its coordinates. So question 11, what are the coordinates of the point at the vertex of the right angle? Well, this dot is the same distance across on the x-axis as this dot up here, and its x value is x2. So that's its x coordinate. And this dot is the same distance upwards as this dot, and its y value is y1. And so its y coordinate is y1. So we found its coordinates, x2, y1. Number 12, write an expression for the length of the horizontal leg of the right triangle. So we want to find out how long this is. We're going to use the same technique as the last example. It will be the absolute value of the difference of the x coordinates. So the x2 subtract the x1 is one way to find the difference of those numbers. Now number 13, write an expression for the length of the vertical leg. So how long is this segment? To find that length, we can use the absolute value of the difference of its y coordinates, the y2 and the y1. Subtract them in either order because the absolute value is what changes it to a positive result. Number 14, use the Pythagorean theorem to write an expression for the length of the hypotenuse of that right triangle. So with the Pythagorean theorem, that's the a squared plus b squared equals c squared formula. And like the last one for the letter A, let's use our horizontal leg. And right up above, we express that as the absolute value of x2 minus x1. That's what we're using for A. Square that. Now plus b squared. For B, let's use our vertical leg. So the absolute value of y2 minus y1 squared. And then the letter C is representing that diagonal side that we're trying to figure out, that distance. And so for right now, let's just leave that as the letter C. So there's number 14. Now question 15. Write a formula that can be used to find the distance in D, the distance between 2 points on the coordinate plane. We're going to take that result, and this time instead of leaving this as C, it tells us specifically, use the letter D for that distance. So we have distance equals. Okay, do you remember in our last worked out example of the Pythagorean theorem that to get that isolated, we used a square root to remove the exponent? Do you remember doing that? We did the square root of 169, and that's how we got 13. So that's what we need to do here. The square root of both sides of the equation is how you can isolate that letter. Okay, there's one other thing that's common to do. Because squaring guarantees a positive number, You don't have to anymore use absolute value bars to guarantee positive numbers in this formula. We can replace the absolute value grouping symbols with parenthesis grouping symbols. I'm building this formula from this previous result. Here is the distance formula. Hopefully you recognize that from algebra class. Number 16, use the formula we just wrote to find the distance between points with these coordinates. All right, so let's tackle this. The distance formula is d equals the square root. In the square root, we're finding the difference of the x coordinates squared plus we're going to find the difference of the y coordinates squared. So let's think about in here, what are these numbers that get subtracted? In the formula, it's x2 and x1. It's the x coordinates, the 12 and the -3. So we have -3 subtract 12. Now, what's in this parentheses up here in the formula? That's your difference of your y coordinates. Your y coordinates are the -5 and the 7. We want the difference. So we want to go 7 subtract the -5. Okay, let's work on this a little bit more. We have this large square root symbol. And inside the first set of parentheses, -3 subtract 12 is -15. Squared plus, in the other parentheses, we have 7 minus -5. That turns out to be 12 squared. Let's keep going. Equals, we have this big square root symbol. -15 squared is 225. Remember how we were able to replace absolute values with parentheses because squaring it guaranteed a positive result? Plus 12 squared is 144. Combining the two terms in the absolute or in the square root symbol, those add up to 369. And then with a calculator, if you type that in, we get the result 3 times the square root of 41. Depending what the context of the actual problem is you're working, you might need that result as a decimal number. And so this is equivalent to 19.2. Here are some check your understanding questions. So in this video, we created the same distance formula that you've used in Algebra 1 and in Algebra 2 class, and we used the distance formula to find the distance between 2 points.